All right, let's go through this extra practice video and see how you did. So here we first have our 3% defective items, and we want to know what's the probability that the box will fail. No more than one defective item per box. Okay, so that means what's the probability that we have no more than one defective item? And so that's no more than one. So that's 0 or 1. That's okay. But if you have more than that, then that fails. So the defective items can be 0 or 1. Now there's 12 items in a box. So n is 12. So we've got 12 with 0 defective items plus 12 with 1 defective items. So that's a PDF with 0 defective items and a PDF with 1 defective items. The reason it's binomial is because we had out of 12 in each box. So that's what I put in my calculator, and that's 95.14% chance. Okay, so here, out of a family of 6, so that's telling me my sample size is 6. I have a set N, so that's binomial. And so getting the flu, so 80% chance that you will get the flu being exposed. So for no one to get the flu, that means all 6 of them do not. So that's 0.2 to the 6th. That's about a 0% chance, so not very likely. Now, for all of them to, that's all 6 of them are 0.8. So 0.8 to the 6th power is your 26.21% chance that all of them are going to get it. Yikesies. Now, exactly 2. So again, this is out of a set number of 6 items. So that's 6, choose 2, exactly 2. So that's binomial PDF. So I didn't write that calculator's part down here, but I did binomial PDF of 6.8, 2. All right, at least 2. So that's an accumulation of 2 successes up to all 6 successes. So I need to accumulate 2, 3, 4, 5, and 6. Well, and again, I usually write out. So if I want 2 up to 6, then I need to take off the 0 and 1. So that's 1 minus the accumulation of 0 and 1 people getting the flu. So that's 0.8. All right. How many would you expect in the family to get? So out of the 6, I'd expect 4.8 on average. Yikes. So quite a bit. And then with this standard deviation, so these are the binomial ones because they are out of the 6. Now, this is interesting. It says they went to church and they exposed 60 church members. So how many of those 60 do you expect to get the flu, and with what standard deviation? So here, that's the N is now 60 with that probability of being infected of 0.8. So that's 48 people. Holy moly. And then with that square root or that standard deviation of 3.10 people. All right, next. Okay, so this is interesting. How few church members would getting the flu? Would it take to convince you that the flu virus does not actually have an 80% infection rate? So we've got to be able to understand this idea that with an 80% defective rate, on average, 48 will get the flu. So an outlier low amount would make me think that this 80% is probably too high of an estimate. And really, about 80, not 80% get infected, okay? So we want to have an outlier low amount. So I'm going to subtract 2 of those standard deviations from 48, and I get 41.8. Now, you have got to think of this and think of which side of the fence you are on. So to be unusually low, you would not be 42. 42 members would be in here on the inside of the fence. You might want to round up to 42 because the number is 41.8. But that is not unusual. It's in the fence. Outside of the fence would be 41. So if 41 or fewer church members came down with the flu, then I would think, oh, we probably actually have a lower infection rate than 80%. All right, next. So this is having these people we want 3 out of the 4 exactly. So 4 and 3 successes who detect that tuberculosis in the x-rays. So 88% chance of detecting that tuberculosis for those who have it. And we want 3 of those successes. That's 0.12, and there would be 1 of those. So this is a PDF because it's a particular number and exactly 3 successes out of the 4. N was 4. Okay, so there's our binomial probability there, 32.71% chance. So here we've got side effects going on, and serious side effects are told to us to happen in 20 out of every 1,000. Well, 20 out of every 1,000, that's 0.02. So that's the rate that we would have serious side effects. All right, so they go and they administer this drug to 15 people, and 3 of them came down with serious side effects. So, how likely was that? So, 15, choose 3. This is an exactly 3. So, this is 3 successes of side effects, 12 not getting side effects. That's this, 0.0029. So, this is interesting. This big time pharmaceutical labs are going to do this. So here's what we have. That wasn't very likely to have that many, because you know what? If we did n times p, so if we did 15 times 0.02, only 0.3, a third of a person on average, should be having serious side effects. This is way, way more. This is way high. So I think we have evidence to dispute this claim. They say that this is the rate of side effects, and I disagree. I think that this rate of serious side effects is actually much higher because we had 3 people have serious side effects when we should have only had like a third of a person on average. Okay, big deal. So we have a geometric with the probability of success being 0.7. How many do you expect to pick in order to get one? Here was that geometric, 1 over p, and then this is the standard deviation formula. So just figuring out the formula. Here we have the probability of getting a 5 is 0.1. So what's the probability they have to score exactly 7 in order to get that 5? So that's 6 failures, and then they get a 5 on the on that 7th person. So 10%. So this is 10% chance on that 7th person. And so 6 failures. All right. What's the probability that the grader has to score at most 3 to find a 5? So that is less than or equal to 3. So they get a success on the first, or they get a success on the second, or they get a success on the third. You could also just show the first in the sequence up to the last in the sequence, which is the third one, and geometric CDF of, ooh, look, I switched that around. That should be saying I want 0.7 to occur in the third spot. So that should be geometric CDF of 0.73. I want 0.7 to occur in the third spot, in and before the third spot. Okay, next. How many do you expect the grader to have to score before finding a 5? So that's 1 over p. 10. Kind of had to score about 10 to get a 5. All right, and now here we go. The probability of a completed phone interview, 0.084. We're going to do 280 phone attempts, so that's a set number of N. We want more than 50. More than 50 means we want 51 up to 280. So if I was thinking about how this works, I want 51 up to 280, so I'm going to take off 50 and below. So that's 1 minus the accumulation of the bottom 50. All right, so that's 0.00802. So wow, if you're sitting there, not very likely that you're going to get more than 50 interviews completed out of 280. All right, exactly 45. That's a PDF. 280, exactly 45. So there's what I put in my calculator. 45 successes. And then you do 280 minus 45, how you get the 235. All right. What's the probability that not more than 15? So not, as long as it's not more than. So 16 and above, no go. 15 or less is okay. 15 or less is okay. So that's 280, and so on. 280 out of 15 is my upper limit, and I'm going to accumulate from 0 up to 15 successes, up to and including 15. Find the average number of calls that must be made before you get one that's completed. So that's geometric because we're going until we get a success. So that formula is 1 over P. So I'm going to have to do about 11.9 interviews before I'm successful with this formula for the standard deviation. Manufacturer uses the electrical fuses. Defective rate is 0.05. What's the probability that the first defective fuse is one of the first 5? That means our first success is the first or the second or the third or the fourth or the fifth. So I have a success on these different trial options. The first success up to the success on the fifth. So that's our geometric CDF, our 0.05, and then we got success occurring on the fifth or before. How many fuses do you expect to test until you get one? Again, that's our geometric, 1 over P. So I think I should have to just do about 20 fuses to be able to find one that's defective. All right, I think that is all of that extra practice, and I hope that helped you. I hope you're getting a little bit more secure in that. So one more practice before our quiz, so good luck to you on that.